Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about integration.
Minute Math, when you need help you use Minute Math.
We're given this indefinite integral, the integral of 1 over the square root of 16 minus x squared dx, and we have to find this integral. Now, we have some identities here to help us, so our goal is to see if we can rewrite this integral to be represented similar to one of our identities here. Okay, so let's go see which one it kind of looks like, and I'm looking at the arcsine one. I have an a squared and a u squared under here. So we set what a and u are. Well, an a value, if we said a is equal to 4, then we can see, well, a squared equals 16. We got that there, right? And if, well, u is equal to x, u squared is equal to x squared. And so that actually becomes a pretty quick way to rewrite this, okay? So let's go rewrite this integral. I have 1 over the square root of, I'm going to write it as my a squared, so my 4 squared minus, and then I said, well, u is an x, right? So we just have x squared here again like that, okay? Make it a little easier to see, dx. What is that equal to? Well, following our rules, the arcsine here, so arcsine of our u value came out to be the x, right, we said, over the a value, which is the 4, plus c. And there we have the integral. Our final answer is the arcsine of x over 4 plus c. We're given this problem right here, the integral of 1 over 4 plus x squared dx. We have to find this indefinite integral. Now we have our definitions right here, so my goal is to see if I can make this look like one of my definitions. And the one I'm kind of gravitating towards is the arctangent one. We have an a and a u, and a u, but plus they're squared right down there. So let's go figure out what an a value can be. Well, if my a value is 2, my a squared value is 4. That's the value that's right here. If my u value is x, then the u squared is equal to x squared, okay? So how can we, well, let's go rewrite this now in terms of our 2 and x instead of 4 and x squared. Or, you'll see. So that's our integral here. Instead of 4, I'm going to put a 2 squared plus, and then x, we have squared, and then dx. And now we can see with our a value being 2 and our u value being x, we line up with our arctan formula. So now let's go apply that. 1 over our a value, which is 2, so 1/2. We have the arctan here of, just plug and play here, our u value is x, and our a value was 2 here. And don't forget our plus c. And so the integral here, just using our definition, is 1/2 arctan of x over 2 plus c. We're given this problem right here. The integral of 1 over x times the square root of x squared minus 1 dx. And we have to find this indefinite integral. Now I have my definitions here, and I want to see which one it looks closest like. And that comes down to be the third one here. It kind of looks similar to the arcsecant definition here. So I'm going to see if I can rewrite this or apply what I can put as my u value and my a value here. Now, u value kind of is pretty easy. U, right there, can just straight up be the x, right? And then u squared is x squared. Pretty easy. Okay. If my a value is just, well, 1, what's a squared? Also 1, right? 1 squared being 1. So that actually fits right there. So let's go rewrite it and kind of showing the squared values there, and really just putting a 1 squared here, you'll see. So we have 1 over x square root, x squared minus 1 squared dx. Now it's kind of broken up to look like this form. Applying our rules, 1 over a being 1, so we have 1 over 1 here, arcsecant of, now the absolute value of u, so absolute value of x being our u value, over our a value being, well, 1 again, plus c. Now we can simplify this up a little bit. 1 over 1 is 1. Don't need to write that coefficient. So we have arcsecant of, well, absolute value of x over 1 is just the absolute value of x. plus c. And so my final answer here is the arcsecant of the absolute value of x plus c. We're given this problem right here, the integral of 1 over 16 plus x squared dx, and we have to evaluate this indefinite integral. Now the first step I want to do is see if I can make this look like one of my definitions here. And the one I'm gravitating towards is the first one, the arctangent one. And I want to see if I can rewrite this integral to, well, look just like this. So let's go find our a value and a u value. Well, if a is equal to 4, what's a squared? Well, that's 16, right? Which is 4 squared, correct? And that's what we have right there going on. So it's perfect for us. What about a u value? So if u is equal to just the x here, it lines up. U squared is equal to x squared. So now let's go rewrite it with our, well, a and u value in there. So the integral of 1 over, instead of 16, let's show that as 4 squared, plus, well, x squared, like so, dx. And now we have our a and u value really established, we can use our formula, okay? So, or the definition there. So we have 1 over our a value being 4. And then we have the arctan of our u value, which is x, over our a value, which is 4, plus c. And that's it. Our final answer here is 1/4 arctangent of x divided by 4 plus c. We're given this problem right here, the integral of 1 over x times the square root of x squared minus 4 dx. And we have to evaluate this indefinite integral. Well, I have my definitions right here, and I'm going to try to see if I can write this or make it look similar to my definitions. And the one I'm really gravitating towards is the arcsecant one. It looks very similar. So let's go find what an a value and u value can be here. Well, if I find a u value to be just x, and then, oops, I don't need that. U squared is x squared right there, okay? Lines up pretty good. What about a value? Well, a squared has to equal 4, so if a is 2, a squared is equal to 4, which is equal to 2 squared. Kind of easy to see there. So now let's go rewrite this with really that 2 squared going in for the 4. So we have the integral here of 1 over x square root x squared minus 2 squared dx. And now it lines up perfectly with our arcsecant. So that is equal to, well, 1 over our a value is 2 here, times the arcsecant of the absolute value of u, which is x here, over our a value, which is 2, plus c. And that's it. Our final answer here is 1/2 arcsecant of absolute value of x divided by 2 plus c. We're given this problem right here, the integral of 1 over the square root of 25 minus x squared dx, and we have to evaluate this indefinite integral. Now to do this, I like to look at my definitions and see if I can make my integral look like one of my definitions. And the one I'm gravitating towards is really, well, the arcsin. Looks fairly similar. So let's go find what an a value and a u value can be. Well, if we set our a value here has to equal, well, a squared is equal to 25, kind of lines up. So if a is 5, a squared is equal to 25, or 5 squared. Our u value is pretty easy here. If we just set it to be x, our u squared is x squared. Not too difficult to find. So now let's go rewrite this integral with really just the a squared being 5 squared. So we have 1 over the square root, instead of 25, I'm going to write it as a 5 squared, minus, well, just x squared dx. But now it's lined up pretty exactly as our arcsin. So let's use the formula. Arcsin of our u value we found to be x here, and our a value was 5. And then plus c. And this is a pretty simple problem once you know our definitions. So our final answer here is the arcsin of x over 5 plus c. We're given this problem right here, the integral of 1 over x times the square root of x squared minus 81 dx, and we have to evaluate this indefinite integral. Now I'm going to use one of my definitions here to integrate this, and I want to see which one it looks closest like. And the one I'm gravitating towards is the arcsin. Looks fairly similar. So let's see if we can find a u value and an a value that line up here. Let's start with the a value. Well, we have an 81 right here where the a squared would be. If our a value is 9, our a squared, 9 squared, is 81. Or we can write that as 9 squared. The rest fits pretty easy. U is just equal to x, lines up pretty easily here, and so u squared is equal to x squared. So now let's go rewrite this integral to line up and look just like our definition. We have 1 over our x value being u, so it's just x, pretty easy, square root x squared, but instead of the 81, I'm going to subtract 9 squared, dx. And now from here, I can apply my definition. It tells us we have 1 over our a value, which is 9, times the arcsecant of the absolute value of u, which is x here, over our a value, which is 9, plus c. Don't forget it. And that's it. Our final answer here is just 1 over 9 arcsecant of the absolute value of x over 9 plus c. We're given this problem right here, the integral of 1 over 4 plus x squared dx, and we have to evaluate this indefinite integral. Now I have some definitions here, and I want to see which one can be applied to our integral. And the one that it looks the most like is my arctangent here. Okay? So let's see if we can find an a value and a u value that match up. Well, our a squared is where 4 is. So if I put a 2 to be a squared is equal to, well, 4. Lines up. And if we want to see it as 2 squared. What about the u value? Well, u's easy in this case. Just put an x there, and then u squared is equal to x squared. Not too bad. So now let's go rewrite it. And so it lines up to our definition. 1 over, instead of 4, I have a 2 squared plus an x squared dx. And now it looks very close to our definition. So now we can use our definition to solve this. 1 over our a value, which was 2, times the arctangent of our u value, which is x here, over our a value, which again is 2. Then we have a plus c. I almost said all over, but just a plus c. And that's it. We're all done with this problem, and our final answer again is 1/2 arctangent of x over 2 plus c. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.